Hey there, welcome to another video on math problem solving. This is Bharat Divya from Switchword Academy, and in today's problem, this is taken from a previous IOQM problem. IOQM stands for Indian Olympiad Qualifier in Mathematics. It's conducted every year for high school students in India. I think grade 8 till 12 can actually write it, and it's a qualifier, which means if you clear the cutoff in this, you actually go on to write one of the regional Math Olympiad exams. But anyway, coming back to the problem, and by the way, if you're interested in enrolling it, this is the time to do it because the registrations close sometime in July. It opens up by somewhere in June till July, so every year, and you can try it out. Exam is probably held a little later, maybe in August or September every year. All right, coming back to the question here, we have a 5-digit number of base 10 that has digits k, k plus 1, k plus 2, 3k, k plus 3 in that order from left to right. If this number is m square for some natural number m, as in the 5-digit number is a perfect square, find the sum of the digits of m. Okay, so this is a proper number theory problem. You have the digits, you have the conditions, you have the constraints that you need to create, all the information needed to solve the problem. So how do you actually go about doing it? Now, the key thing is always remember it's about intelligence. Every single problem is testing your intelligence, and intelligence is differentiating and discriminating. It is basically to know the difference between similarities and similarities between differences. Now, when you look at even the question, it says k, k plus 1, k plus 2. It's kind of similar. It has a pattern, except that the 4th digit, the 10th digit of the number breaks pattern. It has 3k. That's where you begin with. That's the clue that you're looking for. So in case I have the first digit, now just let's write down the place values, right? So you have a 5-digit number, and you know the place values are, this is the units, this is tens, this is hundreds, this is thousands, and this is your 10,000. Okay, so this is what you have, and you know that the first one is k and the 10th digit is 3k. Now this is your clue. Why is that a clue? Because now you can think of a range of values for k that will still ensure that the 10th digit is a digit. For example, if k is equal to 1, then 3k is equal to 3, and that's totally fine. If k is equal to 2, then 3k is 6. If k is equal to 3, 3k is 9. But if k is equal to 4, 3k is 12, and that breaks the idea of a digit because 12 now is a 2-digit number. So now you know that k can only go from 1 to 3. Now the question could be like, oh, why not 0? Of course you can work out 0. The problem with doing 0 is that it's no longer a 5-digit number. So you could assume that k cannot be 0. It's a fair assumption to work with. But if you still want to try it out, you can always think about applying 0 and see what happens if you apply 0. So if you say 0, then 0 plus 1, 1, 2, 0, 3. And you end up getting a 1, 2, 0, 3 number. Looking at the last digit, you can right away reject it because this is not a perfect square. No number that ends in 3 will ever be a perfect square. So the 0 can, you can confidently remove it even without doing the analysis, but it's probably like 10 seconds of analysis to tell you that 0 is anyway not going to work. So now you know the answer. K has to be 1, 2, or 3. It cannot be anything else. So let's list down the number in that case. So we have k is equal to 1, k is equal to 2, and k is equal to 3. In each of these cases, what is the value? What is the value of that 5-digit number? So the first digit is 1, the second digit is 2, the third digit is 3, the fourth digit is 3 times this, so it's 3, 3, and the fifth digit is k plus 3, which is 4. Let's do the same thing for 2. It starts with 2, it goes to 3, 2, 3, 4, 6, 5. And then you have 3, which is 3, 4, 5, 9, 6. So one of this is your answer. Now, how can you go about doing it? Because you have a 5-digit number and you know that they are all, one of them has to be a perfect square, which means you eliminate the ones which are not perfect square and you go with the rest. So one of the key ideas is to actually think about how perfect squares are. So perfect squares, any number which goes by the form m squared, will always have digits which end with 0, 1, 2, 4, 5, 6, no 7, no 8, and 9. It has to be one of these 6 digits. What it can't be is, it can't be 2, it can't be 3, it can't be 7, and it can't be 8. So the first test is to always look at the last digit. So the last digit here is 4, 5, and 6, and this completely works. There's no problem with that. So, which means I don't have a filtering criteria just by looking at the last digit. Now I need to go to a digit before that. So let's take the last 2 digits. Right, so let's take tens and units together. Now there's a very key interesting thing. So for example, let's look at all the perfect squares that end in 5. So for example, 25 is 5 times 5, it's 5 squared. 15 square is 225. 25 square is 625. What do you see? The last 2 digits are always 25. So if the last digit is 5, that alone is not enough. The digit before that needs to be 2. That's the only way you get a perfect square which ends in 5. And that itself will tell you that something that ends in 65 cannot be a perfect square. That doesn't work. Okay, now let's take 4. Let's take a couple of examples of things ending in 4. For example, 2 square is 4. 8 square is 64. 12 square is 144. So you get the idea. Now here too, there's a very interesting pattern to see. If you take the last 2 digits, it's 0, 4, 6, 4, and 4, 4. And if you divide any of them by 2, as in you do a mod 2, then the remainder has to be 0. Right? So not only is the last digit 4, even the digit before that ensures that it's always a multiple of 4, which means when you divide it by 4, by 4, then the remainder is 0. Whereas when you divide 34 by 4, 34 mod 4, the remainder is 2. And therefore you can say this 2 is not going to be your perfect square. So what you're left with is this. This is most likely the answer. Now you can go back and work your charm to see, hey, what number is going to bring you to this particular thing. A bit of analysis, maybe a typical function of figuring it out, either with guess and check, knowing that the answer is going to end in 6, knowing that, like 100 square is 100,000 and 200 square is 400,000, and this is somewhere around 345,000. So probably it's going to be somewhere here. And the fact that it's ending in 6 means that it's either 4 or 6. Would give you a couple of tries to figure out what the answer is. Or you could do the typical traditional algorithm of finding a perfect square. In any case, you'll come to the answer that 186 square is the answer. So M here is 186. And therefore, coming back to the question, what is the 5-digit number? The 5-digit number is, find the sum of the digits of M. So M is 186. And therefore, the sum of the digits of M is 1 plus 8 plus 6, which is 15. So the answer to this question is 15. Okay, I hope you like the question. It's a very interesting Olympiad question. I hope you like my approach, the way I have tried to break down the problem and given you what to look for so that you can solve not only this problem but also problems like this in the future. If you'd like to see more content like this, Olympiad questions, approaches to it, and interesting tips and techniques for it, please do like, share, and subscribe, and I'll see you in the next video. Thank you so much.